Okay, well, thank you very much for the introduction there, Decay, and thanks to VSI for inviting me here and proposing the topic of this presentation. Get it up on the screen, I guess. See if I can do it myself. Okay. Now, I can't promise anything anywhere near as flashy as Jose Oliverio, who was a very hard person to follow in a conference. But what I will do is, I guess, take my own slant on this particular topic, latest technologies, and I guess I've focused on the conference theme around sustainability. And so I'm looking at milling technologies from that sustainability viewpoint. I show here on the screen the Oxford English Dictionary's definition of sustainability. It's four lines long. My definition that I tend to think of as sustainability is really the bottom line there, doing more with less. And that's, I guess, how I'm approaching this presentation. So if we think about what we are trying to achieve in the extraction process in the sugar mill, the first objective is obviously very clear. We want to extract the sucrose-rich juice from the sugar cane. And the second one is also, and becoming an even more important objective, and that is to prepare the bagasse for use as a boiler fuel. So if we want to achieve those two objectives, the sorts of things we can do, maximising extraction to a large extent can fit into these four different approaches. One is to maximise the preparation of the cane. Second is to maximise the added water rate or the imbibition rate. Third is to maximise the delivery net compaction at each mill. In other words, how much we are reducing the volume of the cane at each mill to extract that juice. And lastly, to minimise reabsorption at each mill, so that the juice that we have extracted does stay extracted. To maximise bagasse quality in terms of what we can do in the milling process, it's largely about minimising the moisture content. And to minimise the moisture content, it's really a subset of the last two approaches I mentioned under maximising extraction. We want to maximise compaction at the final mill, and we want to minimise reabsorption at the final mill. So what do we know about how to achieve those objectives? Well, firstly, to maximise cane preparation, the approach that's usually adopted is to increase power consumption in the cane preparation stage. In other words, more resources. If you want to maximise the added water rate, it's relatively easy to increase the amount of water flowing. But that always comes back to bite us because we then have to evaporate that water in the evaporators, which requires more steam consumption. In other words, more resources. If we want to increase our delivery net compaction, we need to squeeze harder, increase mill power consumption, more resources. I guess on this list of four, the only one that doesn't require an increase in resources because it's much more subtle, and that is to minimise reabsorption. So, from the sustainability viewpoint, taking the easy approach, four of our approaches don't really pass the test. Now, rather than just write off those options, we need to think about how we can be a little bit cleverer. What else can we do with our use of power and steam so that we, don't increase our use of resources in those areas. And I'm going to be focusing on some of the other things that we can do to be more sustainable. So first of all, talking about cane preparation. Worldwide, there are essentially two main devices used for cane preparation. There are knives and there are hammers. Now, knives were primarily designed to cut cane. And where we're talking about manual harvesting, whole stick cane, then knives obviously serve a purpose in cutting the cane into smaller pieces. Hammers, on the other hand, were designed to smash the cane. And smashing the cane is what cane preparation is really all about. Now, I don't really have any scientific proof, but from my own observations from studying the cane preparation performance in many factories, I've come to the conclusion that hammers use about 1/3 of the power of knives to achieve the same preparation. So, in terms of sustainability and trying to improve improve extraction, improve cane preparation without increasing power consumption, it makes sense to reduce the use of knives as much as possible. So I asked the question, is it necessary to have more than one set of knives? Where manual harvesting has been eliminated, as we have in Australia many years ago, we now do all of our cane preparation in every factory using a single shredder. Another thing that's one of our current research activities is acknowledging the characteristic that when you prepare different cane varieties, and most probably different blocks of cane of the same variety, with the same, I guess, physical treatment, you do not get the same preparation. Some canes are easier to prepare than others. And so there is potential to do changes with control to things like shredder speed and the shredder grid setting with different cane deliveries. It may be beneficial to reduce power consumption with soft canes and increase preparation or increase power consumption on harder canes, and so give a better overall extraction result without increasing power consumption. As I said, that's something that we're still currently working on. With the added water rate, I guess it's fairly well understood that there is a need to maintain good extraction. There is a need to increase the added water rate in proportion to the cane fibre rate. When it comes to doing that with a control system, well, there are many different ways in which added water rates get controlled. One is simply to have a constant added water rate and be able to manually adjust that as conditions require. Another is to vary the added water rate when the cane rate changes. And I guess a simple way of doing that is to change it with the speed of the first mill. Or getting a little bit more sophisticated, either measure or estimate the cane rate and change it with that. Some of the things that have been done in Australia, many of our factories analyse cane analysis using NIR in the feed chute or donnelly chute of the first mill. And so, given a measurement of cane fibre rate online and an estimate of the cane rate, we can estimate the fibre rate. So it is possible then to vary the added water rate with the cane fibre rate online. I'm not convinced it's actually worth doing. It's one of the difficulties is that the time frame within a milling train, a milling tandem, can take 5 to 10 minutes for the fibre to move from one end of the milling tandem to the other, and then another 5 or so minutes for that water or the juice that's extracted to work its way back to the second mill. By then you've probably moved on to another delivery. So when you make a change is not particularly obvious. One of our factories also makes changes to the added water rate with the pole rate on the basis that it's easier to extract pole from high pole canes, and so then becomes a question of whether you're better off trying to take more where it's easy or devote the water that you do have available to the places where it's not easy, which is often the higher fibre or harder canes. Again, the answers are not completely obvious. We haven't done enough work to really understand this well enough. Moving on to the third approach, in terms of dealing with delivery and compaction. One thing that's well known is that for the same compaction, the amount of power that's consumed changes with the size of the mill and the design of the mill. A smaller mill will consume less power. A 2-roll mill will consume less power than a 3-roll mill. Of course, one of the key points that needs to be added into that discussion is that required capacity is a constraint. And generally speaking, when you reduce the size and reduce the number of rolls, you also reduce the capacity. So 2-roll mills basically have a significant advantage in terms of reduced power consumption to 3-roll mills. And that's largely because they don't have a trash plate. If we think about a 2-roll mill and a 3-roll mill with the same size rollers, the 2-roll mill will use only about half the power of a 3-roll mill. But of course that's not really considering apples with apples, because the 2-roll mill will not have the same capacity as the 3-roll mill. To maintain that capacity you need bigger diameter rolls. But nonetheless, the principle that 2-roll mills use less power than 3-roll mills is fairly well appreciated. And there are a lot of different 2-roll mill designs currently available, many of them available here in India. One area that is a clear winner is to use more efficient drives. Using more efficient drives, you can achieve the same power consumption in the mill without, but use less overall power consumption due to lower losses. So where mills are still driven by steam engines or steam turbines of lower efficiency, we've seen them being replaced by higher efficiency electric motors, using either a hydraulic transmissions or variable speed drives and mechanical transmissions. We've seen in some places the crown pinions replaced with individual roll mounted drives, presumably with also reductions in power consumption. And more efficient mill couplings being used. We saw at the 2016 ISSCT conference, JPMA reported reductions in power consumption of about 8% using rope couplings. And at the ISSCT conference in this last year, we heard of the tailflex coupling, and there are other designs of couplings that also reduce power consumption. I guess when we're talking about power consumption, we tend to think more about squeezing hard and things like that. The power is a product of torque and speed. So you can still squeeze very hard, and reduce power consumption if you can reduce speed. And reducing mill speed is largely, in terms of how it can be achieved in a mill, is largely about doing a good job of controlling the level of the gas in the feed chute, in the Donnelly chute. If you are controlling the chute level, then you are minimising your mill speed. Moving on to reabsorption factor. Lotus rolls are gaining in popularity. We've seen massive numbers of lotus rolls being taken up in Central and South America. They work particularly well with the 4-roll mill in that they can be used to avoid the issue of juice flowing over the top roll. And the recent innovations we've seen, to a large extent, are related to reducing clogging and maintaining performance over the cycle. The images, most of the images there come from a Colombian company, but here in India, SB Resellers had a similar product. One area that takes a bit of cleverness is understanding that groove profiles have an impact on reabsorption. What's not so clear is just how best to take advantage of that. What I've shown on the slide here is an image of two ways in which the gas can be compressed between two rollers. The top approach there is really considering the grooved surface of the roll as a series of supports to compress a blanket. In the second diagram there, we are seeing the gas fold around the groove profile. And if you think about it, the top approach, where the grooves are being used to compress the blanket, is going to achieve a much better compression than the second. We're not wasting energy in trying to bend the gas around grooves. So how do we do that? Well, conceptually, smaller pitch helps. More supports along the length of the roll. And I guess the complementary approach, because smaller pitch is not necessarily the answer, is to have larger work openings. They achieve more or less the same result. Experiments we've done just in simple compression tests suggest that wider angle has an advantage, but I'm not convinced of the practical application of that. I guess the things that we need to consider when it comes to grooving is, first of all, whatever groove profile we use has to be sufficient for drainage, and that generally requires smaller angles, not wider. And we need to be able to maintain our grooves in good condition, maintain the roughness. And that generally means that small pitch grooving is not all that great. Another approach that seems to be gaining in popularity is the use of Meineke chutes in various shapes and forms, such as the duck beak scrapers that ISCHEC have used, and the moisture control units from JPMA. So these are basically chutes or sorts of chutes that follow the delivery nip of a mill. And at ISSCT, JPMA presented in last year improvements in extraction performance through 26 different milling tandems using this type of technology. If we look around the world, there are a lot of different trash plate designs and different setting approaches used on those trash plates. Now, I fully expect that the trash plate design and setting will have an impact on reabsorption factor, but it's a very complicated part of the mill, and it's not at all obvious how best to achieve those reductions. I mean, we do see a wide range of designs, a wide range of settings, and they all seem to work in terms of performing the function that they're there for. Some recent work from VSI here has recommended quite a large clearance between the heel of the trash plate and the delivery roll. 60 to 70 millimetres. That's much larger than we use in Australia, and I'm not convinced that we could do that with what I suspect is softer canes that we have. We have a particular problem with fibre falling down between the end of the trash plate and the delivery roll, so we tend to make that gap small. Another aspect associated with sustainability is the fact that there is an incredible amount of wear that occurs through the extraction process. A result that, or a measurement that was presented at ISSCT last year from Argentina reported that there are 16.5, or that they measured 16.5 grams of iron lost per tonne of cane processed. Now, if we scale that up, that's 16.5 tonnes of metal lost per million tonnes of cane crushed. So we're talking about losing one roller every year in many factories. That's an awful lot of metal that's lost. And reducing wear from a sustainability viewpoint must have a place. Some of the approaches that are used in mill rollers to reduce wear include the application of picots on the surface of rolls, very common in Central and South America. An area that is used in some parts of the world that we are doing some work on now is to clad the sides or the flanks of the grooves and also use higher strength, higher durability cast irons to reduce the wear. There's still plenty of potential. So that's, I guess, the main points of my presentation. I guess the easy approaches to improve performance involve extra resources, which from a sustainability viewpoint is probably not the best way to go. But having said that, there are potential for improvements in control to make better use of resources, and also, as I've talked about, changes in design which can also achieve those objectives. Reducing reabsorption is a very sustainable way to increase outputs without increasing inputs. So it's an area that certainly deserves more attention. Thank you.
Thank you, Geoff, for an excellent presentation in all aspects of building. Questions from the house? Yes. Please be brief.
Thank you for a good presentation. I am Thede from SS Engineers Pune. I want to know what is the safest maximum preparatory index to be maintained. Number 1 for mill tandem. Number 2 in case of diffuser.
So that last, you said diffuser at the end, did you? Yeah. Okay. Different parts of the world have different views on preparation. We have long maintained a target of around 90% as a target for pollen open cells, similar to preparation index. And I guess the work that I've done more and more in recent years has shown me that the better the preparation, the better the extraction. Preparation has a big effect on not just making the cells open, but in making the gas more compressible, so that compactions all the way through the milling tandem are higher. So that gives you lower moisture per gas as well as higher extraction. So yeah, I am a believer in high preparation, high levels of preparation. There are times when you can have too much preparation, and our experience has been that certain varieties of cane are too soft for high levels of preparation. Or perhaps I should be saying that the average sort of treatment that we apply to our cane when you're processing soft cane gives you too high a level of preparation, and we have to back off. We personally haven't had a lot of experience with diffusion. We have 2 diffusers in Australia, and they're both the gas diffusers. And I guess with diffusion, as far as preparation goes, high preparation is better for extraction, but flooding becomes an issue if you prepare too well, and that's, I guess, a bigger issue with the gas diffusion than cane diffusion. So our factories still aim for around about the 90% preparation index, and I think it's still a good target to aim for.
I'm SD Code General Manager, Rajaram Babu. Can you throw light on NIR, how it is benefited and clogging is avoided?
So NIR it's a technique that's used by, I think it's 14 of our 24 factories, and it's been developed over a very long time by Sugar Research Australia to have a satisfactory calibration. One of the issues with NIR is that it needs to be constantly calibrated to keep it reasonably accurate. So it's not something that you can easily jump into. It's thousands and thousands of samples need to be analysed in the laboratory alongside the NIR scans to develop reasonable calibrations. Our experience started with fibre as the primary parameter of interest, even though it's a rather strange one to be measuring, but it's the one that we made use of first, and since then we also we now have good calibrations for bricks and coal as well. It's one of the peculiarities of the Australian cane payment system is that we analyse the juice, first express juice, rather than the cane itself. And so when you're using NIR, although you're looking at the cane, because of the way our cane payment system works, you're trying to infer what the actual first express juice, bricks and coal are. So it's a strange way of doing things. It's the way we've developed in our country. Does that answer the question?
R.P. Patil, work manager from Kanpur Sugar Factory. Like other factors affecting on reabsorption, does the hydraulic pressure on the mill affects on the reabsorption, and what should be the hydraulic pressure to be kept from first mill to last mill to avoid reabsorption?
I guess from my own personal experience, I haven't noticed any real effect of hydraulic pressure on reabsorption. I guess my usual approach is to load up every mill to its capacity. So whatever hydraulic pressure is sustainable without causing cracks in the roll shaft and things like that. Get as much work as we can out of each mill to maximise the delivery of compaction out of each mill.
Geoff. Hello. Sorry.
Just 1 minute. You must complete. You mentioned about varying the speed of the shredder. Is it online variation, or you know that soft change is coming and then you set the speed?
So some of our shredders have the capability of online variation in the speed of the shredder. We haven't implemented strategies yet to vary with different, or it's not common for us to be varying with different canes that come in, but it's something that we're looking at right now. Yeah, well, we had problems with soft canes back in the late 1980s, and we didn't do a lot of changes with speed, but we did make some adjustments with grid setting. But speed is a very effective way of changing preparation, and I think it's an easier approach if it works.
You have the last
Geoff,
question. Last question.
Geoff, can you hear me?
Yeah.
Right. Geoff, great presentation. I just want to ask you, are you aware of developments in material sciences which can sort of address the issue of significant wear, or checking the wear that you mentioned, 6.5 grams to even 5 grams, in terms of new alloys and what have you? Is there anything in the sort of pipeline that you're aware of?
Thanks, Arvind. I can't say I'm an expert in material science or metallurgy. I guess the approach that we are taking, we have traditionally used grey cast iron, as have many mills, and I guess we're probably following rather than leading at the moment in terms of taking an interest in SG iron as probably the next best, the best path forward, in that it's not too much more expensive, but it's a lot harder and a lot more weldable. So I guess we're in a sort of transition state at the moment, in that we have traditionally arced our rollers to roughen them, and the grey cast iron we use in our roll shells has been specially developed to produce globules of roughness when it's roughened, when you apply the arc to the roll. Now, when we want to start looking at longer life surfaces, such as the picots or other approaches that are used to coat rollers, you then start to need to use proper welding processes. And grey cast iron is not very weldable. So something like SG iron is much more weldable and a much better basis to apply a long life coating to, as well as having much more durable in its own right.
I would like to add the like SG iron, most of you exposed to Guatemala and other South American countries. These rollers are mostly SG iron. And they also, it has better weldability than grey cast iron.